Yesterday we went through some pendulums with your pendulum lab. Before I get too much into pendulums, I want to take a little detour and talk to you a little bit about sine curves. I wanted you to see the sine curves in the lab yesterday, and for the next couple days I want to make sure that you understand how to create sine curves mathematically and all the different properties of them. I want to start by reminding you that a sine curve happens whenever you have a certain type of repetitive motion. So with the pendulum, it moves in a repeating pattern. In this case, back and forth motion, but it doesn't have to be. You'll notice we trace out a curve that repeats itself over and over and over again in a consistent pattern. These patterns can be called sine curves or cosine curves, and really they're the exact same thing, as we'll see when we go through this. Okay, we want to talk today about the term period and the term frequency. We use these a little bit in your lab. I just want to remind you that period is the time it takes for the repeating cycle to happen once. Time to happen once. So if I was to time it starting now and ending now, that would be the period, the time for one complete cycle. Period is marked by the letter capital T, and period is measured in seconds. Okay, if I was trying to get the period from this sine curve, I look at where the sine curve starts. I go through one complete cycle, and that's when I get back to where I started, which happened to be the highest point, and then I trace down, and this period would be 2 seconds. So period again is simply the time for one cycle. You read it right off of the thing here, and you do it by looking at where you start and waiting until you get back to that exact same part of the curve. Frequency is very similar, but frequency tells you how many times it oscillates in 1 second. Realize it might be less than 1. For instance, this goes less than 1 oscillation in a second. It might go half an oscillation or a quarter of an oscillation. That's okay. Frequency does not have to be a whole number. Okay, the way that we would get frequency for this one is instead of counting an oscillation, you do 1 second. We go 1 second, we look at where we are, we look at where we started, and hopefully you can see we did half of a cycle. We swung from the farthest point to the closest point to the pocket lab. That was half of a cycle. So the frequency here would be 0.5. Frequency goes by the letter little f. Don't make a capital F. That's force. And it's measured in hertz. And what hertz means is simply cycles per second. So this would be 0.5 hertz or 0.5 cycles per second. It's that easy. Here's another example. So again, if I want to get the period, I look at where I start, I do 1 complete cycle, I trace down, and I'm at half a second. If I want to do frequency, I go to the 1 second mark, and I count my cycles. 1, 2. Remember, don't start counting right away. Wait until you get back to your starting point. Your starting point is 0 cycles. So that's 1, 2 cycles in 1 second. So the period was half a second. The frequency was 2 hertz. 0.5 seconds per cycle. And this is 2 cycles per second, or hertz. Another example, again, just to show you. 1 second, we count them, 1, 2, 3, and the period would be the first one. We trace down, and we're somewhere around 0.33 seconds. Hopefully you see there's a connection. The more cycles we fit in a second, the less time each cycle takes. So as frequency gets higher, the period gets smaller. And that's the connection. It turns out they're reciprocals of each other. So if you have the frequency, you take the reciprocal of the frequency, you get the period. If, on the other hand, you have the period, you take the reciprocal of that and you get your frequency. So they are simple reciprocals of one another. So if I asked you to find your period based on your frequency or vice versa, just reciprocalize them. So if the frequency is 5, the period is 1/5. Don't write it as a fraction, but do it as a decimal. It takes 0.2 seconds. 0.2, 0.2, 0.2, 0.2, and 0.2, that's 5 times to get up to 1 second. If, on the other hand, it takes 10 seconds to do a whole cycle, then it only makes 1/10 of a cycle per second. Again, 1/10. Don't write it as a fraction, write it as a decimal. If it happens 4 times every second, each one 1/4 of a second. And again, if we're at 0.3333, that means we get 3 cycles per second. Okay, if you have one that's not easy, try not to just do a single cycle. So if I wanted to find the period, yeah, I could kind of go here and ballpark it, but that's not going to be very accurate, especially with this ball in the way. Instead of doing one cycle, count many cycles. All right, so I'm going to count them out. Here's 1, 2, 3, 4, 5, and I'm going to stop here because I'm right on a line. I can get real accurate. That's 2.8 seconds. And again, I went through 1, 2, 3, 4, 5. So if I want to get the period, I would go 2.8 seconds. Here we are. And that was for 5 cycles. Reduce it to a decimal, and you'd have so many seconds per cycle. If instead I wanted the frequency, I would just reverse it. I would go 5 cycles over 2.8 seconds. I would divide them, and I would get my frequency. They are reciprocals of each other. Period is seconds per cycle. Frequency is cycles per second. Okay, that's all I'd like you guys to do in terms of notes today. Please share your notes with me and then work through the problems on the Google form. Make sure I get a picture of your notes and make sure I get the Google form filled out. Tomorrow we'll go a little farther into sine curves. I just didn't want to overwhelm you with a long video on any of these days. All right, thank you. Have a good day.